Before we will start getting physical, let me explain the core concepts of this program. First of all, we're observing the process input, and I want to focus on this part because this part is the most important part. First, the main function initializes a few variables and chunk of memories like the VRAM array. It contains all the information about what we're seeing right here, the entire pattern, the information of the entire pattern, all these tokens, symbols, numbers, and characters. The audio commands pointer actually contains all the encoded data. The encoded data of the entire song, not just one pattern, but the entire song. So let's start in the process input. The process input actually is the function that contains the information about the interrupt handling. So if we have input hardware like a mouse or the keyboard, it's processed here. So we have functions like the transpose selection function or the fill cells function or the delete selected data function, and all these functions exist to put in stuff here. So the fill cells function, for example, if you press a key like A, you will have a C note put in here. That's handled, or the task of the fill cells function is to write that information into the VRAM. After that, it gets encoded by the audio encoder. The audio encoder basically writes the data coming from the VRAM into the audio commands pointer in an encoded form, of course. So it is compressed, but more later on. So what else do we have? Stuff like this is pretty self-explanatory. Well, we have a swap pattern left, right, and left. We can gather data for copy, right? When you draw a selection, I made it as global variable, so the arrow just goes into one direction. Two directions mean actually that you give data to this function, and the function actually writes data back, especially to these two guys here. Not so for the gather data for copy function. It just fills up a global array that contains somewhat 2000 bytes, so we can make the selection of an entire pattern. I mean, you have 28 columns times 64 rows, and that's around 2 kilobytes on information that we want to save. And then you use the paste cells function to put it anywhere you want. So this is how this stuff works. It's not very interesting. So let's go to the next function, the draw everything function. The draw everything function draws, as the name suggests, everything. It's the most important part is the draw sound data function. The draw everything function actually just draws stuff like these rectangles here, or this cursor here, or when you right click the menu and you see the menu with the selection of where you can select transpose or adding a new pattern and stuff like that. That's done by the draw everything function. The draw sound data function actually decodes the information of the current pattern and puts these information, writes these informations into the VRAM. And the VRAM actually sends all this data to the text processing unit. I colored this field here red because all these other functions here end up here in this text processing unit. So what else do we have? The create row counter function, for example. Create row counter function has the task to render this stuff here. The row counter actually from 0 to 64. We have the function draw pattern display. It's actually this stuff here. it handles the variables of this stuff. We have create right-click menu text. It's the text in the right-click window, and yeah, that's it so far. So let's go to the text processing unit. What actually does this function? Well, it processes all these tokens, symbols, characters, and numbers we have seen. We can send just a single character or number, but you can also send an entire string or word to this function, and all these symbols are actually just bitmaps from my 32-bit large number. As you can see here, all these zeros represent transparency or the background, and while the ones represent the actual pixel that are being drawn. You have, yeah, as you can see here, this is a 1. This should represent 1, and in another order it would look like this. It's just a regular 32-bit number. So, but we have 6 times 5 numbers actually, which would be 30 bits, right? So we just have 2 excess bits that are unused. And we are converting this number to decimal and present it that way, store it that way in our array, and it gets converted back to binary and drawn as bitmap. That's what the text processing function does. It gets another information from outside, from the other functions, like where these numbers, characters are to draw, in which coordinates, how many it are, where they are, or not just characters, as I already said, but entire strings. As you can see here, you have load, you have save, wave editor, and stuff like that can also be processed by this function here. Yeah, that's it. So how does the graphical user interface, the GUI, actually work? So let's go to this, guys. I've already mentioned that the audio commands pointer is the complete encoded music data, and the VRAM is the random access memory for the visible commands. That's not actually just the visible, but everything you have in a pattern. And well, first we start here at the process input. We fill our cells with stuff, or write new commands into the VRAM, and the audio encoder after that encodes the new comments and sends it to the correct position in the audio commands pointer, right? We have a large data stream. In this data stream, we have to point to in the right direction, and there has to be stuff written there. And yeah, that's it. After we have done that, we go to the draw everything function. The draw sound data actually converts from the audio commands pointer back to the VRAM the actual data that is needed, so that it can be sent to the text processing unit. So it goes this direction and then back in this direction. It updates itself all the time, every 30 milliseconds, and this is actually the proof that it works when you put in stuff here in the audio encoder into the audio commands pointer, and the audio commands pointer actually gives that information back to the VRAM. And if nothing changes, then this is the proof that these two functions here, audio encoder and draw sound data, actually work the way they are intended to work. Yes, that's how the GUI works. And all we have discussed now is the edit mode actually. Now let's talk about the play mode when we're playing the music. So what you can see here is actually one row cycle. So this is just one row here, row 4 for example, in this time somewhat 10 milliseconds, 10 to 20 milliseconds, depending on how you make your adjustments. Well, first of all, we have our process input. We start from here. I mean, if you put the base key, it will start to play. Then it goes into the draw everything function. After that, we're approaching the audio decoder. The audio commands pointer actually gets is being decoded, and that decoded information gets put into the aux array. Right? We have in one row we have 28 columns with 28 cells, and commands. We have these commands, and every could contain a piece of information, and that's put into the aux array. It could also be a zero value, of course, as you can see here. Not every cell is filled up with information. Could also be the case, and the program, the knowledge stat recognizes that. So what else do we want to explain? Yeah, we have the buffer. For example, the buffer is also a large chunk of memory, and when we are going to the when we accomplish the decoding, the aux array puts the information into the pulse generator, the wave generator, and the noise generator. Stuff like frequency or volume or duty cycle is processed here, and these generators write information or process the information that gets put in the buffer, and that's actually somewhat 4,000, 5,000 bytes large buffer. And yeah, after that, after the data is processed, it gets sent to the hardware. We have this library initialized. It's the simple direct media layer library, and it handles all the hardware stuff. So the bytes that we generated in the buffer and processed in the buffer is queued to the DA converter. Yes, and then put out to the speakers, right? That's what happened here. We don't have to worry about that. That's all the stuff that SDL and the operating system does for us. Yeah. So what else do we have? You eventually approach after that the cut pattern function, the jump pattern function, or the play next pattern function, depending on what settings we have made here, right? If you put in here a C, it cuts the pattern depending on which row we actually read in. If we're here on position 14, we have set our C here on position on the last column, then it will cut there, won't play the next row, it will start a new pattern. But if we just leave that out, it will play just the next row and start from begin. This whole process will start from begin. So this is basically the entire program, the functionality of the program and how it works.